Welcome back. This is tutorial number 2, using Latent GOLD to estimate DFactor models. I'm Christine.
And I'm Michael.
And we're going to do the analyses shown in tutorial number 2 and discuss the output. Before we get going though, I'd like to make a few introductory remarks. First, this tutorial builds off of the results obtained in tutorial number 1. So if you haven't done tutorial number 1 yet, you may not have the files that we'll be using here. Also in tutorial number 1, we introduced the Latent GOLD program and the data set. So you might want to look at tutorial number 1 for that information as well. Second, if you're not reasonably familiar with the topic of discrete factor models, you might want to read some of the articles posted on this topic on the Statistical Innovations website. These articles are very accessible and they're not too long, so it's well worth your time to have a look. Finally, we'd like to point out that various parts of the procedures and output that we'll be seeing here are very similar to other types of analyses with which you may be familiar, such as exploratory factor analysis, confirmatory factor analysis, and cluster analysis. So with all that stuff out of the way, let's get going. Here we're going to skip over the first page of the tutorial, but we strongly suggest that you read it very carefully. Now towards the bottom of the page, you'll see figure 7-26. This figure relates the four-class solution obtained at the end of tutorial 1 to the upcoming analyses. The point of this is that in tutorial number 1 we assumed that there was one latent factor and that it was a nominal categorical variable, meaning that the categories weren't ordered in any particular way. In this tutorial, we're going to assume that there are two factors, or latent variables, and that each factor has two ordinal levels. So in other words, these levels are ordered along a continuum for each factor. Now, although this tutorial is only going to use factors with two levels, this idea also applies to factors with 3 or more levels. So let's get going and open up our 3-class model from tutorial number 1. I'm going to come up here and click on my open icon, and I'm going to click here on 3class.lgf and say open. Now the LGF files only save the specifications for the models, not the actual output. I'll double click on that to open up my dialog box, and I'll just click on estimate. Okay, now we've got that. I'm going to come here now and double click on model number 2, and I'm going to raise it from 3 clusters to 4 clusters, and then I'm going to estimate that model.
So this gets us warmed up kind of where we left off from tutorial number 1, and with tutorial number 1 there was kind of this issue of which model is better, 3 cluster versus 4 cluster, and that's where we're going to kind of pick things up.
Yep, and now I'm going to actually rename this. Now that it's highlighted, I click on it one more time, and I'm going to rename it to 4 class so that we remember what this model is. And in general, it's probably a very good idea to name each of the models as you go through, because once you get more than a few models, it's hard to remember what the difference is between each of them. So now that we're here, let's have a look at the parameters. So we click on our parameters thing, and we want to start to notice some things about our output. Now let's look here at cluster number 2 for purpose. And we see that these numbers tend to follow a scale. And we look here at cluster number 3, and these numbers tend to follow a scale. And the same here with cluster 4.
And what we mean by that is that the values as you go from good to depends to waste, that they go in increasing, either consistently increasing or consistently decreasing.
And let's look also at the other trichotomous variable, cooperate. Whoops, look at this one here. And again, you see the same pattern, and here you actually see it for all 4 clusters. Up here for cluster number 1, you don't quite see the pattern, although it's not too far off. So now that we've had this peek here, what we might want to do is say, can we use this information in a way that's going to save us some degrees of freedom?
And we could do that by making the variable ordinal. And when you look at the variable, you go, that kind of makes sense. That for the purpose, that looks like that is kind of an ordered variable, not just a nominal variable. That people's purpose, that they view the purpose of surveys going from waste on one extreme to good on the other extreme, and kind of it depends in the middle. And likewise with respect to cooperation, going from impatient and hostile on one side to interested in on the other side, and cooperative kind of being somewhere in the middle. So that kind of makes sense.
It does make sense. And so let's come here. We're going to actually double click on Model 3 here to open this up. And what we're going to do is click here. I'm going to press the Control key on my keyboard so I can select this variable as well. And now I'm going to right click. And this brings up this menu, and I'm going to select Ordinal here so that I have changed these two variables from nominal to ordinal. Okay, so now that we have that, let's come down here and click on Estimate. Okay, so now we've got the estimates here. Now let's click up here at the very top on our data file name so that we can compare our models. Okay, so what we're really looking at is this 4-class model versus this model that we just ran here. And there's a couple of things that we do want to see. First off, we see that we have saved 6 parameters being estimated, so the difference here is 6, and we see the corresponding increase in our degrees of freedom. So that's good. Now let's look here at our likelihood ratio chi-squared, and we see that the change here is really tiny, especially for having gained 6 degrees of freedom.
So in this situation, when you have a small change in the fit of the model for a big gain in degrees of freedom, that suggests to me that that was a good change in the model, and that it would be a good idea to treat these variables, instead of the 3 level variables being nominal, to treat them as being ordinal. It makes common sense, and it makes sense in terms of the model.
That's right. So now, in keeping with the spirit of naming models that we've done, I'll highlight here, click one more time so I can get in there and rename this, and I'm going to call this 4-class ord, for 4-class ordinal model. So now that we've got that,
So now we're moving on to page 5 of the tutorial. We're assuming that you're following along with us on the tutorial.
actually we're up to page 6 already.
Yeah, we just turned to page 6.
Yeah, so let's come down here and we're going to click on our parameters so that we can see the parameters.
Actually, let's go to the profile, because then that'll show us figure 7-34 right there.
Okay, so
There
we go. And there's a couple of things that we want to notice. First off, these probabilities up here are unconditional probabilities, and these down here are conditional probabilities.
So those unconditional probabilities just give us a sense of the size of the clusters, and those add up across to 100%. So the biggest cluster here is cluster 1 with about 52% of the folks, and the smallest one is cluster 4 with about 8% of the folks.
Okay, now let's have a look here at our conditional probabilities and see if we see any patterns here.
Now let's mention that when we're talking about conditional probabilities, we're talking about the probability, for example, of, given that you're in cluster 1, what's the probability that you said that the purpose was good, or that the purpose depends, or that the purpose of surveys is a waste of time, noticing that those add up to 100% going downwards.
Okay. The other thing we want to notice is that between cluster 1 and cluster 2 here for purpose, that the patterns are looking pretty darn similar. And if you come down here to understand, we see that the patterns are similar between cluster 1 and cluster 3. And again, we see this for the fair-poor for cluster 1 and cluster 3. Now what this is suggesting to us is that maybe what we really have is a 2-factor model.
So what we might have is, as you saw on the first page of the tutorial, you might have this kind of 2-by-2 arrangement. So instead of having just 4 nominal clusters, we might have 2 discrete factors forming this 2-by-2 arrangement.
And what we're really doing here is moving from a latent class cluster model to a dichotomous factor model. So this is where we're going to make the switch between the different kinds of models. I'm going to come over here to Model 4, and I'm going to right-click on it to open up our dialog box, and I'm going to select here DFactor.
So this is for doing a discrete factor analysis.
And I am going to change the number of factors from 1 up to 2. And now we're just going to go ahead and estimate the model. There we go.
Now, by default, we're getting a two-factor model, each of which has 2 levels to it, because that's the default number of levels. So 2 factors, 2 levels for each, 4 clusters
groups.
total.
All right, let's come back up
Or
here
4
to
groups
the
total.
Let's come up back up here to the top and do our model comparison again. And what we want to look at here is this 4-class ordinal model to the model that we just ran. And we see here that we have actually saved 5 parameters from being estimated. We see the gain here in the degrees of freedom. We got 5 degrees of freedom. But we notice here that we've got not quite a 7-point gain here. It looks like a 6.3875 gain here in the likelihood ratio chi-squared. Now we need to stop and think. We can't do the little trick we did previously where we said, boy, that change is so minuscule, it's less than the degrees of freedom. Hey, we know right away it's not statistically significant. Here we actually have to run a test to see if there is a statistically significant difference between here.
So there are 2 ways that we can do that. One way is to do a chi-square test, which assumes that the difference in the likelihood ratio chi-squares follows a chi-square distribution. The other is doing a conditional bootstrap. We'll show you each of them. So here we're starting at the top of page 9 of the tutorial.
We're going to select View, and we're going to select Prob Chi here. Now here we put in the difference between the two, which you have to calculate yourself.
Yeah, that's just a hand calculation.
7. So it looks like that. The degrees of freedom we know is 5. So we do that, and then we click right here, and we get a p-value of 0.27.
Woohoo, not significant.
Not significant. Now, you could have looked this up in a textbook if you wanted to, but this is just kind of a nice convenience thing here. So we have the 0.27. Let's see if we get some sort of similar result doing our conditional bootstrap.
Now, here we're saying not significant, but maybe what we should do is make really clear what the null hypothesis is that we're testing. What we're testing here, let's go ahead and close that window, is what we're comparing is the 4-class ordinal model to model 4 there, which is the 2 DFactor model, and it's testing whether the fit of model 4 is significantly poorer than the fit of the 4-class ORD model. That null hypothesis is not significant, saying that it does, even though it's got more degrees of freedom, even though it's got fewer parameters, it does not fit significantly poorer.
Okay, so now that we have that, let's go ahead and move on to our conditional bootstrap.
The second way that we can test this, and this is a good way to test it if you are fretting that the difference in the distribution of the likelihood ratio chi-squares are not distributed as chi-square.
Now, you may wonder, gee, which one should I use if I don't know? As far as we know, you never really go wrong using the conditional bootstrap. So, you know, if in doubt, that's probably the way to go. The cost of doing that, however, is in computational time. So you will notice that when you do the conditional bootstrap, it's going to take a whole lot longer to run, but, you know, if that's the right way to do it, or if you're not certain, that's the best way to go. I'll click here, and we get this. Now this here is the list of our eligible models. So we are going to select our 2 DFactor model right here, and then we're going to click on OK.
So we've selected one model. We originally selected one model. We picked the model that we're going to compare against, and now it's computing, and it's going to do this process twice. It's computing it's going to do 500 bootstrap samples, and then it's going to take those 500 bootstrap samples and run it for one of the models, using that exact same set of 500 bootstrap samples, run it for the other models. That's why you see it doing this process twice. Can you snip it? Okay, you can see here that we're getting close to the end of the second run for the 500 iterations. We're waiting anxiously for the results, and here we go.
Okay, so here is our bootstrap p-value, and we get a value of 0.2120. Now you'll notice that that number is slightly different from what you see in the tutorial, which is 0.2000, and is probably a little bit different from the number that you got if you're following along and doing these analyses in Latent GOLD as well. That's because this is a bootstrap procedure. You're drawing random samples, and so you shouldn't get exactly the same value any 2 times you do it.
Exactly. And when we did this as a chi-square test, we got a p-value, if I recall correctly, of about 0.27. So this gives us a good warm feeling in our heart that both of these tests are suggesting the same thing, that the two models are not significantly different from each other.
Okay, so now let's look. Okay, so now why don't we come up here? We're going to click on Model 4, and what we
Actually,
are...
Model 4 boot is what we want to look at here.
Okay, so why don't we click up here on our Model 4 boot, and what we're looking here for are these two p-values. So this is the p-value just computed for the chi-squared. This is the bootstrap p-value, and what we see is that they are both statistically non-significant. They're actually very close to one another, and the hypothesis that's being tested here has to do with the fit of the model.
So this is just kind of a basic goodness of fit test, asking about the overall fit of the model. And both of these tests are suggesting this is a good fitting model. So we're doing well. And by the way, the model we're talking about here is the 2 discrete factor model.
Okay, so now let's expand here so that we can have a look at some of the output that we've got here. We're going to expand our parameters here, and now we're actually going to look at the loadings. And when we say loadings, many people will think back to exploratory factor analysis, loadings, from that, and actually you can think of them in exactly the same way. What these really are correlations between the indicator and the factor, between this indicator and this factor. Now this R squared column here, R squared, it harkens back to, say, OLS regression when you're thinking of amount of variance accounted for, or you can think of it in terms of an EFA, in terms of a communality. So this is actually the communality here, meaning that this is the amount of variance that these two factors are accounting for in this indicator.
Now, based on what you know about communalities, you might be tempted to take 0.6692 squared plus 0.0966 squared, and you might notice that there's a little discrepancy between that value and 0.467. It's going to be really close, but it's not going to be exactly the same, and that's just due to the fact that this isn't exactly a regular factor analysis, but the results will be close.
Right. Actually, the difference has to do with this not being exactly a linear model. So
now, because we can interpret these as factor loadings, we can draw upon the sorts of things that we do to interpret factors. When we look at this, we can try to see, do we have kind of a simple structure here? So like for factor 1, we see that purpose loads on factor 1, but not really factor 2. Accuracy loads on factor 1, but not factor 2. Understanding loads on factor 2, but not factor 1. Cooperation, it's kind of it's not really loading real heavily on one or the other. So it seems that we could interpret factor 1 as being people who kind of believe in surveys or have a tendency to think that they have a good purpose and that they're accurate, whereas factor 2 seems to be related to that they seem to understand the survey when they took it, and maybe that they were a little bit cooperative as well. So maybe factor 1 is believing of surveys and factor 2 is kind of understanding of surveys.
now let's digress for a second here and click on correlations. And what you'll notice right away is that this part here is exactly the same as we saw before on the loadings. Again, is suggesting that these are actually the correlations between the indicators and the factors. The new part up here has to do with the correlations between the factors themselves. Now, we have by default specified that the factors are not correlated. However, you can actually specify that the factors be correlated, and this is where you would look to see how correlated they actually are. And a little later we will show you where it is in Latent GOLD that you make that specification.
The other thing that you notice is that some of these factor loadings are pretty darn close to zero, and on page 11 there's a heading about restricting loadings to zero, and that's where we're going next. Where what we're going to do is we're going to take some of these loadings that are pretty darn close to zero, and we're just going to force them to be zero.
And the reason we're doing this is, as always, we're looking to regain degrees of freedom. Okay, we want to have kind of as many degrees of freedom as possible.
And we don't want to estimate parameters that are just kind of nuisance, no useful, serve no use.
That's right. So that is what we're going to do here. So we are going to come over here to our Model 4, which is our 2D factor model. I'm going to double click on this to open up our dialog box, and I'm going to click here on the Model tab. So now that we have this, we see that factor 1 is highlighted to begin with, and so I'm going to come over here and I'm going to uncheck understanding. By unchecking this, what you're telling Latent GOLD is to just set that parameter to 0 and don't estimate it. Now, if you remember from the previous output, the loading for understand was about 0.05, so very, very close to 1, and that's why we're going to do this.
Very close to 0.
Very close to 0, thank you.
Yeah.
Okay, I'll click here on factor 2, and for purpose, I'm going to uncheck it. In accuracy, I'm going to uncheck it, and you remember that those were like 0.09 and 0.06, again, very close to 0. So that's what we're going to do. Now, if you look down here to the included associations, if you checked here, what you would be telling Latent GOLD is that factor 1 should be correlated with factor 2. By default, it's not checked, which is why the factors weren't correlated when we were looking at the output. If you wanted to make them correlated, this is where you would do it, and you would check right here.
Now, another thing that you notice here is that there's this add button, and what that would allow us to do if we wanted is we could change the number of levels for a factor. You see currently right now DFactor 1 has 2 levels and DFactor 2 has 2 levels. You could select a factor and then click add to add levels to that factor. We're not going to do that right now, though.
No, what we're actually going to do, though, is come down here and click on Estimate. So we get our model, and now we're going to rename this here. So we click on it once, and we're going to do 2 DFact, and then we'll do restrict to tell us that it was the restricted ones. Okay, so we've got that.
So then the thing that's going through my mind is we restricted some parameters to 0. Did the model fit get real bad as a result of doing that? Because maybe that might happen.
Well, let's click up here at the top and find out what's going on. So here is the model that we just ran, and we're going to compare it to this model 4 up here. So you see that 3 fewer parameters have been estimated. Those are the 3 that we set to 0. Again, of course, you see the corresponding increase in the degrees of freedom. And now if we look here at the likelihood ratio chi-squared, we're looking again at about, say, 1.5, again, versus 3 degrees of freedom. We're going to say that that's statistically non-significant without testing it, but if you wanted to test it, you certainly could, and it would be statistically non-significant. Another thing to consider here is the BIC. We're looking here at about 5614 versus 5595. Lower BIC, the better the model. So by the BIC criterion, by the number of parameters, and by our likelihood ratio chi-squared, we're saying that this 2 DFactor restricted model seems to fit pretty darn well.
And if you wanted to compare the 2 DFact restrict to model 4 using the conditional bootstrap, you could do that as well. In this situation, it's so obvious that the 2 models, or that the 2 DFact restrict is doing so well, we're going to just skip that.
However, what we're going to do now is come over here and look at the parameters, since that would be kind of what we want to do. Again, we're going to expand this and we're going to look here at the loadings.
Some of the loadings are 0.
Oh no, some of our loadings are 0.
Oh, of course, we set them to 0.
Oh, of course. Okay, so we got that. And again, we're seeing exactly the same patterns of loadings that we saw previously, which is what we expected. So we got that. Now let's come down here. I'm going to expand our profile. And first off, we're going to click on profile here so we can see this stuff. Now, there's a lot going on in this table, so we're going to go through this a little bit slowly. Again, up here at the top, we have the unconditional probabilities. These are giving you kind of a sense of the size of each of these levels within each of the factors. So it looks like, say, this one is actually pretty big relative to this. This is pretty big relative to this. So that's what this is telling you.
And notice that they're adding up to 100%, that 74 and 25 is adding up to about 100%. That's because we've got D-factor 1 broken up into you're either level 1 or level 2. And then likewise for D-factor 2, you're either level 1 or level 2. These are like marginal probabilities, kind of pretending for in your mind for a moment like this is a chi-square and that these are kind of like row percents and column percents. We can kind of picture that in our mind.
If it's easier, you might want to look back to the diagram on the first page. I think it was 7-26 at the bottom there. And so these 4 numbers correspond pretty much to what you would be seeing in the margins on that table. So now that we've got that, let's come into here and look at our conditional probabilities. Okay, so we see here that we've got this going on here, and we see here, oh, these are all the same. Again, this has to do with our having set these parameters here to 0, and that's why you've got 3 of them that are the same in both places.
So you can see that's a consequence of the factor loading being set to 0, that the conditional probabilities can't change between level 1 and level 2. So if you are on level 1 of D factor 2, your probability of saying good is 0.76, and if you're on level 2, it's also 0.76, because the purpose variable doesn't load on D factor 2. It has no impact. But with respect to D factor 1, that if you're in level 1, your probability of saying good is 93%, versus if you're in level 2, it's only 27%. Seems like D factor 2 has a lot to do with whether you perceive surveys to be good or not. Likewise, you can see the same thing with respect to accuracy. That in level 1, you have about a 65% probability of thinking that surveys are mostly true, whereas in level 2, you only have about a 15% probability. So level 1 seems to be these folks who think that surveys are good and accurate, and level 2 seems to be the folks who think that surveys are not good, they're not accurate.
Okay, and to compare this or relate this back to figure 7-26 on the first page, these numbers here would be the numbers that actually go into the 4 cells. Okay, whereas these were the marginals. Okay, another way to view this is through the profile plot. We can click right here to see the profile plot. Now this isn't shown in the tutorial, but it is a helpful way of looking at these results.
So here you can see that we're talking about D factor 1 here, and you can see, as we were talking about, that level 2 are the folks who think that surveys are not true and that their purpose is not good. And then if we click on level 1 here, you can see that these are the folks who think that have a low probability of saying that they're not true. I'm getting confused talking about this in terms of not true. Can we flip this in terms of being true? How could we do that?
Why don't we do this? And I'm going to click here, and I'm going to click here on purpose.
Actually, on accuracy.
On accuracy? Okay,
Yeah.
and we'll click here and unclick there.
Ah.
And then on cooperate, no, it's understand. Okay, and we'll do this here. There you go.
Okay, terrific. So then that makes things a lot easier. So we can see that this is now expressed in terms of thinking that surveys are mostly true. So that makes a whole lot of sense. And so this is another way that you can interpret these results by having a look at these conditional probabilities expressed in terms of this profile plot. So you can see here that for D-factor 1, that you have for accuracy, they're the folks who think that surveys are mostly true with a probability of about, about 65% or so. And then with respect to purpose, the way that this is scaled is higher numbers means more of a waste of time, a higher value on that purpose score. So they have a lower likelihood of thinking that the surveys are a waste of time. So this factor 1 or level 1 of D-factor 1 are the folks who think that surveys are mostly true and don't think that they're a waste of time, whereas factor 2 are the folks who think that surveys are generally not true and are more likely to think that they're a waste of time.
Okay. The last thing, though, watch your scaling down here, just so that you know how this all matches up to figure 7-48. So we're going to close out of this now, and we're going to move on to looking at the joint profile output. So to do this, I'm going to come up here, I'm going to click on
Profile.
and then on View, and now I'm going to click on Joint. So now we have the output that is shown on figure 7-49. Now again, we have the unconditional probabilities up here, but this is a joint thing. So this is if you're in category 1 or level 1 of D-factor 1 and level 1 of D-factor 2. Here you go. And again, this is giving you kind of the relative size of each of our categories.
And notice that they sum to 100% across all 4 levels, because going back to the first page of the tutorial, looking back at figure 7-26, these are kind of like probabilities that are inside of each of the cells when you form the 2x2 crossing D-factor 1 with D-factor 2.
Okay, so now let's come in here and see if there are any patterns in here that we need to be looking at again. So again, we see that these are the same here and here and here. Whoops, where was it? Oh, here and here. Okay, so we see that we've got the same here again because we had set things to 0. And so what this is saying is that given you're in D-factor 1 level 1 and level 1 of D-factor 2, that your probability of saying good is this 0.9371. So you notice that of course these add up to 1 as you come down the columns here, and we want to remind everybody that we're actually using effect coding for things here.
No.
And the last thing we'd like to mention here is that these are actually weighted means. So if you're trying to reproduce these, remember that they are weighted means.
So by weighted mean, that's saying that you would take 0, was it 0 times?
No, I think it's 1, 2, 3.
Oh, that's right, they're coded 1, 2, 3. So 1 times 0.9371 plus 2 times 0.05 plus 3 times 0.0001 would give you that. So that's how those are coming about.
Okay, so now that we've got this, why don't we come down here and look at this plot again. It's going to be a little bit different because now we have the joint probabilities shown here, and we're going to open up our dialog box here, whoops, to get this going.
So why don't we have a look-see here? So we've got why don't we click on 1-1 here? So this is where we've got for D-factor 1, you're in group 1. For D-factor 2, you're in group 1. And then this is the profile plot that for this group of folks, that they're thinking that surveys are mostly true, that they're having a good understanding, that they are, with respect to cooperation, they're very low, and lower values are meaning more interested. higher values are meaning more hostile. And then with respect to purpose, they have a low score. And with respect to purpose, higher scores mean thinking that's a waste of time, lower scores means thinking good. So these are folks who think that surveys are good, accurate, they have a good understanding, and that they tend to be interested in the surveys. So you can click on the other categories there and see the profiles for the other folks as well. So this is one of the things about Latent Gold. It allows you to interact. In fact, if you wanted to suppress some of the lines, you could come over here and you could click and uncheck the box, and you could uncheck another one, and it allows you just to focus on any particular groups that you want to focus on.
Okay, so now that we've got that, we're going to do things a little bit out of order now, and we're going to jump to page 17, and we're going to look at some biplot displays to help a little bit more with our interpretation of things. So we're going to expand here, and now we'll see our biplot. So this is what we get out of the biplot. And now actually that we've got this control open, I'm going to select the variables here and put in some lines. So I'm actually going to come through and do this, and I'm going to put in all of these lines here. And now it looks like the output that you see in figure 7-53.
So what this is showing you is down here we have DFactor 1. This is the average score for DFactor 1. This is DFactor 2 over here. And what I meant by the average, that this line right here, this is the average score for DFactor 1. This line right here is the average score for DFactor 2. And then for example, for fair poor, if we click on that, given that if your understanding of surveys was fair poor, these are your means for DFactor 1 and DFactor 2. Now you could say have a fair poor understanding as opposed to a good understanding, and notice that what's changing when you go from, whoops, there we go. So when you go from fair poor to good, what's changing is DFactor 2. DFactor 1 isn't changing, so you can see that understanding is highly related to factor 2 and is unrelated to factor 1. Now along this dimension here, it has to do with your sense of the purpose of surveys. So if we click on like waste over there, we can see that this is your way over here, and then coming over here to depends, and then coming over here to, I can't quite remember what that, oh, that's good. So this is your dimension of the purpose of the survey. As you move along that, you're moving along DFactor 1, you're not changing at all with respect to DFactor 2. And then you've got, it's a little bit obscured, but you've got the mostly true versus not true. Again, this is moving along DFactor 1, which makes sense because we identified DFactor 1 as that factor of having to do with surveys are good or not good. I believe in surveys, I don't believe in surveys. So you can interpret this in terms of, I think factor 1 in terms of I think that surveys are good and useful, factor 2 in terms of understanding surveys, and then the cooperation variable is an interesting one because it is, as we saw, it's related to both of the factors, so that when you are impatient and hostile, that you have a high value on DFactor 2 and you have a pretty high value on DFactor 1 as well. So this is a way to help you understand the way that the items and the particular levels of the items relate to the means on DFactor 1 and DFactor 2.
Okay, now that we have that, why don't we jump back to page 16 and talk about classifying cases. So what we're going to look for is some standard classification stuff. I'm going to close out of this, and let's see here. So to get this, we're actually going to have to rerun our model. I'm going to come here and double click on Model 8, and I'm going to come up here and I'm going to look at two tabs. First off, I'm going to look at this Output tab here, and we see here that we can click here on our standard classification. If we estimate the model now, we're going to get this output in our Latent GOLD output, but that's the only place we're going to get it. Now, because these things are pretty much like your factor scores and something that you might want to use in a further analysis, maybe what you're thinking is, I'd like to output this stuff to a data file, such as an SPSS data file. Well, that's found in a different place, so we're going to come up here and click on Class Pred, and again you see here standard classification. If you click here, this highlights this here where you can name the data file, specify its location, and then when you estimate the model, then you have this stuff ready to be output for another program. So now that we've got that, why don't we go ahead and say estimate. So we estimate our model here, and we're going to come down here and look at standard classification. And we see a big table with lots of numbers. So along here in these 4 columns, they specify all the different combinations of the response patterns here. So in this one you said good to purpose, mostly true to here, good here, you're interested. We see that 419 respondents actually had this pattern, and then we come over here and we see that this is the D-factor 1. These are our factor scores here for factor 1, factor scores here, and now we come over here to modal 1 and modal 2. So this is telling us what was the modal response for D-factor 1 and D-factor 2.
So if I had to force to choose a classification for you, I would choose to classify you as being 1 for factor 1 and level 1 for factor 2 because your probabilities were so low. If your probabilities were really high, for example like right here, then I would classify you as 2 for factor 1 and also 2 for factor 2.
Okay, so we've got all that, and now do we have anything else we want to say about this?
Yes, so also what we have here, we have the conditional probabilities for being in each of the factors given the given that response pattern. But that's all of the output that we get in this output. If you have a look on the tutorial in on page 19 on 7-54, you get additional information that's described in the handout right there. And I think that this kind of winds us up here. One of the reasons that we might be outputting these things is because we want to do further analyses, and that's something that you're going to be seeing, or we're going to be seeing together in tutorial number 4, where CHADE is going to be used, which is a different program which can use other predictors to try to predict membership in the factors, to try to understand what sort of things which would predict factor membership.
One last comment. If you look out here, I think this is actually an easier way to see how the modal thing was assigned, because here for 1-1 you're really high, and that's why you're getting put into group 1 here for D-factor 1 here. Here you're really high on level 1 of D-factor 2, and that's why you're going into here.
Oh yeah, I think that that's where it's really coming from, and using those as the threshold cutoffs.
Yeah, so here you see that you're high here on D-factor 1 level 1, but here you're high on D-factor 2 level 2, and that's where you're getting the 2s here.
So, so based on whichever one is the most likely, whichever level has the highest probability is the one you get assigned to.
Using the modal method of assignment.
Great. Well, I think that wraps us up for this tutorial.
Okay.
Hope you had fun.